All right, now that we have learned all of the various ways of factoring, we're going to wrap up this unit with talking about how to factor completely. In algebra, when we factor, we considered a polynomial completely factored if we look at the factors that we have factored and we make sure that they cannot be factored again. So in order for a polynomial to be completely factored, each polynomial factor itself be completely. So let's look at an example. We have 5ax to the fifth minus 5axy to the fourth. So your very first step when factoring is what we learned at the very beginning of this unit. No matter what, if you're factoring a binomial or a trinomial or even a special case, the very first thing that you do, no matter what, is if you look at each term and you look to see if there is a GCF that you can factor out. So this is a binomial, and you'll notice that I have a 5 that I can factor out, an a that I can factor out, and an x that I can factor out. So we'll begin with that. We'll factor out that 5a to the 5ax. And then we're left with x to the fourth minus y to the fourth. And then we will recognize that as differences squares, because x to the fourth is the same as saying x squared. X squared squared, and y to the fourth is the same as saying y squared squared. And so that means that difference of squares says that if you have a squared minus b squared, it's the same as saying a minus b times a plus b. So our a is x squared and our b is y squared. So we end up having x squared plus y squared times x squared minus y squared. And notice how I did not forget to keep writing that 5ax in front. So you'll notice I have 1, 2, 3, 4, 5 different factors. So you might think, wow, okay, so we factored and then we factored again. We're not done yet, because if you look here, this gave us another difference of squares. So we've got x squared minus y squared, which means our a is x and our b is y. So x squared minus y squared is going to change into x plus y times x minus y. So we're going to copy down these first 4 factors, and then we're going to go ahead and factor that last factor into x plus y and x minus y. Now, one more check. Okay, it looks like everything is completely factored. Don't be confused. Remember, there's no such thing as the sum of squares. There's only difference of squares. So this is already completely factored. There's nothing you can do with this guy. Okay, all right. And remember, you can always check your work by multiplying and make sure that after you multiply, you end up with what you began with. Let's look at another example. We have x to the fourth minus 9x squared plus 8. So looking at these, I see that I have x to the fourth and I have x squared. So I could factor out an x squared for those, but then it would cause me to have x squared minus 9, and then I would have a plus 8 hanging off on the end. So that doesn't make sense to do it like that. So what we're going to do instead is we'll go ahead and you can do the box method if you like. But just remember that you're trying to get x to the fourth. So your first terms are going to be x squared and x squared to get x to the fourth. Okay, and then you need factors of 8 that multiply to negative 9. So we would have negative 1 and negative 8, because those multiply to 8 but add up to negative 9. So from here, Notice that x squared minus 1 is one of our special factors. It's the difference of squares. So remember, 1 can be rewritten as 1 squared, which means our a is x and our b is 1. So x squared minus 1 is going to factor using difference in squares to x plus 1, x minus 1. Okay, and then we still have this x squared minus 8. Okay, and then x squared minus 8, you're like, oh, is that another difference of squares? It could be, but you have to check. So is 8 a perfect square? It is not. 8 is not a perfect square. Therefore, you cannot do difference of squares on x squared minus 8, which means we're done. This is it for example 2. This is as far as it will factor. We've got 3 factors here. All right, let's look at this example. Now, this is the first time that we have had a polynomial that has had more than 3 terms, other than our very first lesson when we were just factoring out common monomials. We actually have a 4 terms, and if you look at those 4 terms, our very first step, of course, would to see, can we factor out a common monomial? Do they have any factors that they all share? They don't. These 2 share an x, and these 2 share a 5. However, all 4 of them don't share anything together. So when that is the case, when there are 4 terms, and they don't share anything, what we're going to do is we're going to group the terms together that do have something in common. So for example, those had an x in common, so we're going to group those together. And then these 2 had a factor of 5 that was in common, so we're going to group those 2 together. Notice how when I grouped them together, I didn't put this times this. They're still plus. There's still a plus. So essentially, I haven't changed the expression at all. It's still 2xy minus 7x plus 10y minus 35. I didn't change anything. All I did was I put groupings together using the associative property, actually. So now that I have those grouped together, I can factor an x out of here, and I can factor a 5 out of here. When I do that, I'm left with 2y minus 7 with that x, okay, because that will go back to 2xy minus 7x. And over here, I have factor out the 5, leaving me 2y minus 7, because 5 times 2y is 10y, and 5 times negative 7 is 35. And then you'll notice, hey, there's a 2y minus 7, and there's a 2y minus 7, which means that this term, because that is one term, and this term, they have in common a 2y minus 7. So I'm going to factor out that 2y minus 7, which leaves me x plus 5 as my other factor. We have am minus an minus pm plus pn. So again, we are going to look to see if there's anything that they all 4 share, and there's not, which means we're going to group them together. So we're going to group am minus an together, and then we're going to group this negative pm plus pn. But when we do that, we have to be careful, because remember we have to put a plus in between them, which means that if this is a plus negative pm, then let's make sure that this is plus pn. So just be very careful when you are grouping these, that you don't get confused with your negatives in subtraction. So from here, we can factor out an a from this grouping, and we can factor out a p from this grouping. I suggest that you go ahead and factor out a negative p, because we really don't like a negative to be in the front of our factor. So when I factor out the a, I'm left with m minus n. When I factor out the negative p, I'm left with m minus n, because negative p times m is negative pm, and negative p times negative n will get me back to that plus pn. So from here, you'll notice, hey, this factor and this factor, or this term and this term, because there are two terms here, share the m minus n. So we're going to factor out the m minus n. And when we factor out the m minus n, I'm left with an a minus p when I factor out the m minus n. So I have a minus p times m minus n. So all four of these terms do not have anything that's in common with all four of them. So since they do not, we will start with grouping the first two terms and the last two terms together, making sure that we pay attention to these subtractions that will become negatives. So we have 2y cubed plus 5y squared as our first group, plus we have negative 8y minus 20 as our second grouping. Now that we have our groupings, we will go ahead and factor out within those groupings. So for this group, I can factor out a y squared. And when I factor out a y squared out of this grouping, I'm left with a 2y plus 5. And then over here, remember I said you typically don't like to have a factor that has a negative, so we're going to go ahead and factor out a negative, and we're also going to factor out, let's see, we have 8 and 20, so GCF would be 4. So we're going to factor out a negative 4 from this group right here. So when we do that, we're left with 2y plus 5. It's plus 5 because we have to be able to go back to negative 20. And negative 4 times 5 is negative 20. Then you'll notice that this term and this term both share a 2y plus 5. So I can factor out that 2y plus 5, leaving me y squared minus 4. So now I have y squared minus 4 times 2y plus 5. Is that the final answer? So you have to remember, to be factored completely, we have to look at, after we factor, we have to check again and say, okay, do any of my factors need to be factored? So for example, y squared minus 4 is the difference of squares, which means your a is y and 4 is 2 squared, so your b is 2. So y squared minus 4 is going to become y plus 2, y minus 2, okay, or y minus 2, y plus 2. And then 2y plus 5 is fine as a factor. That doesn't factor any further than that. So that means that this is actually factored completely. All right, so that is how you factor polynomials completely.